Our task is to write the truth table of the logical statement if P, if and only if Q, then Q. Take note that the biconditional is part of a grouping symbol before we allow the conditional statement of that result, then Q. The number of rows for our truth table is still to be determined by this formula, 2 to the power of n. And we have P and Q propositions, hence this is 2 squared, giving us 4 rows. So we need to construct a truth table with 4 rows, excluding our header. The header will have P and Q. So this would be our first column, and this is our second column with 4 rows. 1, 2, 3, 4. For the first 2 columns, we just need to place a truth value for each of the proposition. So let me also enclose this in as a row, but this is for the header. So the first column for P, let's have here true and true. For our Q, you will have true and false. To complete the first column, you will have here false and false. For our second column, true and false. Examining the pairs, all combinations are there. So we need to start with the logical operator biconditional, as it is part of a grouping symbol, and it's simply the biconditional if and only if we have for P, if and only if Q. The truth value for biconditional statements will allow us to provide true results if both statements are of the same truth value. Hence, both statements P and Q in this perspective would be either true or both of them are false for the entire statement to be true. So for our first row, true and true, under biconditional logical operator, this is true. Second row, true and false, they are not of the same truth value, this is false. Next, you have false and true, different truth value, this is false. And finally, you have false and false, even if both of them are false but they are of the same truth value, the biconditional result is true. Now after this, we simply need to subject this into the conditional statement, our original logical statement. If P, if and only if Q, then Q. This is conditional. So we still have 4 rows indicated here. For some of us, it might be difficult for you to always turn your heads here because for conditional statement, we cannot interchange them. It should be the hypothesis for the result for the biconditional statement, and then the conclusion would be Q. There is a suggestion that you could always rewrite it here just for your perspective. True, false, copying the entire second column. You may not need this, but a suggestion, you may write it here for it to be guided. And take note that our logical operator here is conditional. The truth value to be true for conditional statement is this: if both, number 1, if both hypothesis and conclusions are true, automatically the result is true. And the second situation is, regardless of the truth value of your conclusion, if your hypothesis, that is for your if P, or in this case if P, if and only if Q, is false, regardless of whatever your Q is, automatically for conditional, it would be true. So looking into this perspective, you have first row true and true. Both statements are true. Under conditional statement, that is true. Next, we have here false. Regardless of whatever is your conclusion, as long as your hypothesis is false, also true with the third row, automatically this is true and this is true. Okay, so regardless of your conclusion, as long as your hypothesis is false, automatically for conditional logical operator, the result is true. Finally, we have here true this is false, they are not of the same truth value, and your hypothesis is true, automatically this is false. This is now the truth table for your logical operator if P if and only if Q, then Q. Don't forget to like and share our videos, leave a comment, and reasonably subscribe to our channel.